Hey, welcome. We're going to continue our work with factoring that we started yesterday in 7.5 with 7.6. It's going to be a part one. We're not going to go too far into section 7.6 today, but we are going to do a little bit, so stay tuned. And there's going to be a few questions for you along the way. All right, so the first thing we're going to do is review 7.5 a bit, just to remind you of how we did three-term factoring. And three-term factoring was when we had x squared plus 11x plus 28. We're trying to work backward to find the multiplication problem in the parentheses that would multiply out to that as the answer. And the way we did that last time is we did it with the box. It's not a very straight line there. So we did it with the box, and what we realized was the first term always went in the first box, and the last term always went in the last box. And then we needed the middle term split between that diagonal, those two boxes. So x squared plus 11x plus 28. So really what I had every time is I had x and x. And that's the part that's going to change a little bit in 7.6. And then I needed two numbers that were going to multiply to 28. So I'd put them here and here, two numbers that multiply to 28 and add to 11. So two numbers that multiply to 28 and add to 11. Think of those numbers and enter your answer when you're ready. So hopefully you thought of 7 and 4, positive 7 and positive 4. So 4 times 7 is 28, 4 plus 7 is 11. So on the diagonal I'd have 7x and 4x, which does add to 11x. Then my answer would be x plus 7 times x plus 4, the factors on the outside. And at that point, we are good to go. All right, so that's kind of the process we learned last time. I want you to go ahead and try one more. And the one more we're going to try is x squared plus 4x minus 12. All right, so I'm going to end up needing two numbers that multiply to negative 12 and add to 4. You're going to go ahead and work that out with the box. So go ahead and work that out with the box and enter your answer when you're ready. So in the end here, I needed two numbers that multiply to negative 12 and add to 4. Those numbers are plus 6 and minus 2, because plus 6 times a negative 2 makes negative 12, and 6 and negative 2 add to positive 4. 6x and minus 2x are going to add to 4x on that diagonal. So what I'm left with then is x plus 6 times x minus 2. Hopefully you're able to enter that as your answer on this one. All right, so example 1 here is going to be our first 7.6 question. And the main difference between 7.6 and 7.5 is that there's a number in front of x squared. In 7.5, all our problems were just x squared plus a number x plus a number, right? So these guys, the green ones, were numbers last time, but that blue one was invisible. It was always 1x squared. And so that's going to complicate things quite a bit as we move into 7.6. Now, there's two possible options for what we're going to have to do with that number. The first option is we might be able to pull out something called a GCF, which we've worked with before. And that's when there's a number that divides all three parts evenly. And example 1 is going to be a setup of when there is a GCF. In this case, hopefully you can see that 5 divides all three of those parts. And so since 5 can divide all three of those parts, I can pull it out of my trinomial here as a greatest common factor. And once I've pulled it out as a greatest common factor, I can think about what would like multiply back in 5 times what to make the inside parts. So 5 times x squared would make 5x squared. 5 times 3x would make the 15x, and 5 times 2 to make 10. So I end up with 5 times x squared plus 3x plus 2. So one thing we might have to do is if there is a GCF, pull it outside, and then we'd be able to factor what's left on the inside, right? So I'd be able to factor with the box my 3-term trinomial that's left on the inside. And that's a problem that would look like the review, right? X squared in the first box and plus 2 in the last box. I need two numbers that multiply to 2 and add to 3. So figure out what those two numbers are. Multiply to 2 and add to 3 and enter your answer when you're ready. Yeah, 2 and 1, and 2 is a prime number, so it's obvious because there's only one option of things that multiply to 2, 2 and 1, right? And then I have 2x and 1x, which does add to 3x on that diagonal. So I'm left with x plus 2 times x plus 1 out of the box. And then the only thing I have to remember is I still have this 5 out here that kind of is coming along for the ride. It's a part of my problem. It's my GCF that I factored out. So I'm left with 5 times x plus 2 times x plus 1 as my answer. All right, let's try example 2. And example 2 is going to be one where there is no GCF. And we should pretty much be able to know there is no GCF because 13 is a prime number, 3 is a prime number. There's nothing really that can divide those numbers except themselves. And so there's not really anything that works overall, right? So no GCF. So if there is no GCF, we have to go straight to the box and start our 3-term factoring right away. My process is the same, but the hard part is going to be there's a lot more options to consider in the multiplication. So I still am putting my 4x squared in the first box. I'm still putting my plus 3 in my last box. But this time I have a lot more options for what I'm going to pick in order to do the multiplication. And the reason why is now I have 4x squared in my first box. So I can't just put x and x. So I put x and x, that's going to multiply to x squared, not 4x squared, right? So I'm either going to have 1x and 4x, or I'm going to have 2x and 2x. It's either going to be 2 times 2 or it's going to be 1 times 4. But I'm not going to know right away which one to pick. And then with the 3, its prime number should have to be 1 and 3, right? So what I'm going to kind of do is I'm going to put my 1 and 3 in just because there's kind of only one option there. So it's a little easier this time to put my 1 and 3 in than it is to put my 2 and 2 or 1 and 4 in, right? And then I'm just going to try. I have a few different options here, right? And so I'll try 2x and 2x. Maybe it'll work, maybe not. And then I'm going to multiply into the boxes and add up the boxes. And I need this diagonal, these two boxes, to add up to 13x, right? So when I multiply into the boxes, my top right is 3 times 2x, so 6x. And my bottom left is 1 times 2x, which is 2x. 6x and 2x makes 8x, which is not 13x. So 1 and 3 and 2 and 2 did not work. Now, I can kind of cross that option out because it did not work, right? So now I can try 1x and 4x. So if I put 1x and 4x in, now when I multiply in, I'm going to get 3x and 4x. Which 3x and 4x is going to add to 7x, right? And that's not what I want either. I need 13x in the middle. Which is confusing because now I've used both my options and neither one worked, right? What we need to realize is when I'm pairing up the numbers, it actually matters which order you put them in. Like last time in 7.5, it didn't matter which side I put the multiples on. But this time it does, because right now I'm pairing 4x and 1 with 3 and x, right? But if I had put my 4x here, then it would be paired with my 3, And 4x and 3 is going to multiply to 12. I'm almost all the way to 13, right? So I have to be a little bit clever here about the way that I'm pairing my numbers together. So I'm going to go ahead and do that and pair my 4x with 3, because that puts me almost all the way to that 13 I want, right? So I'm still going to do 4x and 1x, but I'm just going to swap their spots. In the 7.5, that didn't change our answer, but in 7.6 it will. And so I have 12x here, and x times 1 is 1x. And now that diagonal does multiply or add up to my 13x in the middle that I needed, right? So it worked. My answer then would be 4x plus 1 multiplied by x plus 3. All right, let's go ahead and set this one. Factor 3x squared plus 7x plus 2. So whenever you're asking yourself these questions, the first thing you have to ask yourself is, if that first term, which in this case is 3x squared, is not just x squared, has a number there, we have to ask ourselves, is there a GCF in this problem? Is there a greatest common factor? And if there is, the first thing we have to do is factor it out. So in this question here, is there a greatest common factor? Yes or no? Enter your answer when you're ready. No, on this one there wouldn't be, right? Because 3, 7, and 2 are all prime numbers. So 3 is the only thing that divides 3x squared, but 3 won't go into 7 or 2 evenly, and we need it to go into both evenly if it was going to be a GCF. So I'm going to draw my box down here. I should automatically know that 3x squared goes in the first box, plus 2 goes into the last box. And I need two numbers that are going to multiply to 3x squared in the first box, which is a prime number, so it has to be 1x and 3x. And then for my last box, I have to be 1 and 2. So on this one, since there's only one option for the first one, I'll just put 3x and x. And then I have to decide, am I going to put my 1, 2, and my 2 up here, or am I going to reverse it and put my 2 here and my 1 up here, right? So the way we're going to do that is try it out and see which one is going to yield a result where those two boxes add to 7x in the middle. So go ahead and try both those options, figure out which one works, and then write your answer as a product of factors and enter your answer when you're ready. So if you tried the 1 here and the 2 here first, you would have ended up with 2x and 3x, which adds to 5x. Now, if you do that first, it's not wrong. We can't be scared of being wrong on these problems. That's fine. We just have to readjust it. As soon as you find the wrong answer, you actually know what the right answer is, right? 1 up top didn't work, so now I'll try 2 up top, and that's my only option left. So it better work. 1x and 3 and 2 makes 6x. And 6x and 1x does add to 7x there. So now my answer at that point would be 3x plus 1 times x plus 2. One little trick is a lot of times, like I can see that 3 and 2 are going to make 6. So pairing them up, that gets me pretty close to 7. That might help me make a good guess from the start. This is just a start, just a taste of 7.6. We're definitely going to continue with it next week. So thanks for staying tuned, and I'll see you next time.